So this one's a little bit harder. You got to make sure you're careful with this. So BAC is right there. So that's 19. And then it says CAD, which is this angle here. All right, it's 24. Now, what I'm going to show you is that that green angle is actually not super helpful. It's not, by itself, it's not super helpful because it's not in a right triangle. All right, so there is my blue right triangle right there. The other right triangle, if I highlight it in the orange, see the little green here. The orange right triangle is going to be right there. All right, so now that green angle is a problem, all right, because it's only 24. I'm going to put the numbers in. That one was 24. That one was 15. I really need to know this full angle so I can use it for the orange triangle. Well, that's just those two added together. So that angle is 39. Now, again, that's a little minor difference here that gets tossed in. Oop, I did not do that right. It's 19. Sorry. Start doing some little stuff. Okay. All right. That's how I put it down. That's 19. So then this is 43. Okay, regardless, I need to know the angle of the orange triangle or I cannot do this. It also tells me that AB is 145. Okay, what do I want to know? I want to know BC, so I want to know this. How am I going to get that? All right, well, same thing I've been doing. So I'm going to find this side. We'll call it A. I'm going to find this side. We'll call it B. Then I'm going to do B minus A. And it's going to spit out the question mark. Okay, like I said, if you did 3, there are some adding ones. Make sure you skip down and try a couple of the adding ones just to be safe. All right, see what is the difference. This is a SOHCAHTOA problem like it's done for the other ones. So let's go ahead for our blue triangle. Let's label our sides. So our blue triangle, hypotenuse is right here. Opposite is over here. I would make this the adjacent. So I want to know the opposite and I know the adjacent. So again, this is going to be a tangent element. And if you did the previous sections, I told you that these real, quote unquote, real life problems are often tangents because we can measure horizontally and vertically very easy in real life, but not diagonally all that often. Okay, so the angle is 19. The adjacent is 145. I don't know the opposite. I know the angle, so it's going over 1. Okay, so I got that. So I'm going to do tangent of 19. So tangent of 19 is 0.344. Blah, blah, blah. I cross multiply. I get x equals 49.927. 49.927. Blah, blah, blah. And now I got to deal with this orange triangle. Okay, now again, the outside bigger triangle is a little bit harder to picture at first. So hopefully we're getting a little better at it. The hypotenuse of the orange triangle is there. The opposite of the orange triangle is going to be here, not the question mark side, it's the whole side. And then that's going to make the 145 the adjacent again. Okay, I want to know the opposite. I know the adjacent, so this is going to be another tangent problem, and that's no big deal. Eventually, if you do all of these practice problems, I know there's at least one where it's not the same, but they're the same most of the time. The angle is 43, not 24, and the adjacent is 145. We don't know the opposite. So I know the angle, so I put it over 1, and it's a cross multiply problem. So 0.932. And then I cross multiply, and I get x equals this 135.214. Blah, blah, blah. This is side B. This is side A. I'm going to subtract those two. So that side minus that side. 85.287. 85.287, blah, blah, blah. It says to the nearest inch. All right, doesn't say tenth or anything. That means I got to round no decimals.